Hello everyone, and in the last video, if you remember, I had a disclaimer that I'm going to present you not a production ready code, so we should be able to, but it didn't really run code. So right now it's about time to talk about the production ready coding and what it means, how to implement those best practices, and how to write that kind of reliable and scalable software. So without further ado, as usual, let's roll and discuss what is a production ready code in the first place. And as you can see on the screen, there are a couple of main bullet points that you can say. And the production ready code, in general, it should be something that is easily maintainable, so you can write new functionality to your existing applications without big issues. Then, after you come to the same code in 1 month's time, you should be able to get to the gist of it and understand what is happening, why it is happening. So the code needs to be readable and well documented, and don't rely on your memory or anyone else's memory to get that information, why something is working, what is the idea behind it. It should be documented somewhere. Then the code should be efficient and performant. So if your application is taking 5 minutes to load and run a single query, no one will actually use it. So what's the point of having that kind of an application? And then if it is full of defects or bugs and anyone can get the details and personal data of all of the other users of the application, then it is once again not so good as it could be. And the last but not least, and I put it here in quotes, it should be fully tested. And by fully, it is based on your requirements. And in some organizations, it could be as low as, I don't know, for example, 50% of code coverage that is required. But you should have that kind of setting somewhere and agreement that the code needs to be tested and tests have to be implemented. So with those five main points, it is pretty much what you want to have, and maybe a couple of words of why. Is that first of all, if you write a good quality code, so it would be a production ready code, it prevents downtime of your application, so everyone is happy. If you have to support your application and it is down, you don't want to wake up in the middle of the night to fix it quickly because there was some sort of a defect or I don't know, some scary and hooded hacker decides to break your application right now when you're having a good time, then it is easier to maintain in the long term, and it's always fun to see when your product evolves and growing bigger and bigger in a professional sense. And finally, from that professional sense, when you write a good code, you would have that kind of a warm feeling inside of your uh, breast that you actually did something good and something nice. So let's talk about the best practices on how to define and see that the code that you're writing it is good enough and it is production ready. So from readability point of view, and on top of that, from the documentation point of view from the previous slide, it is that it's better to use a descriptive variable names and not just I, A, and so on, and one letter variables. Then you need to follow a consistent code style, and even better if you enforce this kind of style with a linter, and that can be of anything like a Google Java format or ESLint or Prettier and so on. And even better if those tools are used in the CI/CD pipeline as part of your test. Then you need to write comments sometime, but first of all, do not overcommit in terms of comments, and not every single line needs to be commented out. And when you write those comments, you have to describe of why something was done and not how it was done. So if your comments just repeat the next line, so you have a comment for each element in array, and on the next line you have a for each loop, it doesn't really make sense. But if you describe of why you are doing something, it's much better. And finally, that when you write the code, it needs to be understandable. And quite often, speaking about the documentation, code is the best type of documentation because the code is always up to date if it is committed quite often, and the documentation is always lagging behind. But uh, that's our world pretty much. Next thing that I wanted to say about the good practices is that you need to handle your errors correctly so the application doesn't crash. And when those errors and issues arise, and if your application is not something the simplest of ever possible, then there would always be some sort of an issue, and sometimes they are outside of your own control. So you use some sort of a third-party service, and that can time out sometime or just being down. And you need to be able to see what is going on. And the good production-ready code, you have a good monitoring tools, both in terms of the application logic, if something goes wrong or not, and in terms of the infrastructure performance. So the metrics like CPU usage or the memory usage of your services, all of that is important and will help you tremendously when you will need to support your application later on. And if your year isn't it's not crashing the whole application, then it's even better. So once again, I will give you a quick reference to the previous video about the Go applications that I wrote. I explicitly said that, and then I decided to not break the whole thing when the health check was failing for the pizza database connectivity or something like that. But that's following this line of thought. Obviously, it didn't really work out for that last video, but that was the whole idea of it, just to have a good demonstration. Yeah. And then about tests, as I said before, your code should be tested, and it should be tested on many, many layers. So usually you have at least the unit tests, but even better if you have the integration tests and end-to-end tests. And I might just present a separate video on different types of testing and what are the goals of those tests. But pretty much it's really nice to have documented somewhere in your documentation what is your testing strategy and what is your acceptable levels of code coverage and how everything is tested and how often everything is tested. And just for the simplicity, it's better to use testing frameworks like Mocha or PyTest or Jest and so on. So everyone or the new developers who would join your project later on, you basically have the common ground and you know what to expect when you see a test written in PyTest, for example. And it's a good rule of thumb, but not necessarily always the case. But I would highly recommend to get it as warnings are errors, and if it is not tested, then assume that it is broken. Because someone will come later on, and that someone can be you 1 week later, and just change the functionality and lose some of those existing use cases that were supposed to be maintained. Uh, the next is the very personal favorite of mine, the security considerations, and I take security really seriously in my real projects. But for proof of concept project, usually you don't have it. That's why you haven't seen that much of it from my end so far. But the general rule of thumb over here is that for the security, you pretty much have to implement and check for the OWASP top 10 vulnerabilities and keep on scanning for them. And even more or even better if you would try to implement something like a security application framework from OWASP once again. And basically, the very first thing that you need to do is to sanitize the inputs and never write database queries with direct uh, string concatenation and always use parameters when you need to make those queries from user input. And that will basically prevent the vulnerabilities like SQL injections and cross-site forgery requests and so on. For the performance, Uh, One thing that I would say first is that over tuning of things and premature optimization, it is a root of all evil. But still, in order to make your application usable and production ready, you need to have it performing fast in an optimized way. And for that, based on those metrics that you saw in your monitoring part, you need to know that this request takes a little bit too long for everyone's taste. So it needs to be optimized. And how to do it is that most likely you would need to optimize the database and then check your logic and where possible run the asynchronous processing where appropriate and where it is possible. Obviously, it will make your application and the logic a little bit more complex to understand, but it really pays out. And finally, to have caching where possible and as much as possible to just speed up things. The good example of this would be for my favorite pizza application. If those pizzas, and we know that they don't change that often, maybe it is enough to read those pizzas only for the first time ever when the application starts or when it first accesses them, and then to refresh this cache periodically once a day or something like that. And that's up to the business requirements to decide how and where to implement those caching strategies. And the final part is deployment readiness, and this is another one of my favorite topics. It is CI and CD pipelines. So if your application is production ready, then you definitely have a CI/CD set up somewhere. It could be a GitHub Actions or Azure DevOps, and you probably could guess and check my Udemy video about those if you are interested in terms of the deployments to Azure. And then, in terms of the good practices, you have to enforce code reviews. So the pull request to your main branch or your working branch, they shouldn't really be allowed to be done willy-nilly without any reviews. And at least some other developer, apart from whoever making that push, should review and approve the pull request. Obviously, it's for their not proof of concept projects, but for the actual real projects where more than one person works on them. And for the infrastructure, you have to use pretty much tools for the infrastructure as code. So it would be Terraform, and most likely you would Dockerize and containerize your application and run it as a Docker image. Sorry, you need to create an image from your application and run it as a Docker container somewhere else, and that will help for the maintainability and just proving that if application was working in a container somewhere, so for example on your local laptop, then it will be fine on another server, so on the cloud. Finally, how to avoid the common pitfalls and how to learn from your mistakes, because that is the best way to learn from them. And the common pitfalls is basically you could over-engineer your solution ahead of time and make everything so complex and so hard that you never finish your project. And the best example for this one would be the game development. And a lot of new developers who want to write their own game, they will start with their own 3D engine and never finish the engine because it is very complicated. While as to have a good motivation, you first need to see some sort of a result right away and gradually and slowly improve that initial implementation with more and more features and with more and more content pretty much. Then, as I said, if you skip the documentation and you come back to your project 1 month later, you basically have to start new, and it's quite complicated and would be really bad for you. Uh, and I'm speaking from my own experience. And the last one is to neglect tests due to deadlines or just due to laziness. And it's always better to write those tests, at least unit tests, at least for some of your code base, not necessarily have a 100% coverage, but do include them even in your proof of concept project and just learning activities too, because that's a matter of habit, and it is a very good habit to always write good tests for your application. And by good tests, I mean that they will actually test the logic and not just have a code coverage in order to have a code coverage. And what is my recommendation for that walkthrough and how to get to the production ready code quality is that first you start very simple and implement whatever is needed for your feature as quick as possible with as easy solution to understand as possible. Then you need to apply the best practices to have it tested, have it logged, and have the security checks in place. Then deploy it via the CI/CD pipeline, and maybe you will need to implement that CI/CD pipeline. And after that, using the logs and metrics from your application, verify that the feature that you developed in the first place, it is doing what it is expected to do and how it is expected to do. So if it's fast enough, it is correct enough, and so on and so forth. And on top of all that, even better if you would verify that the feature is actually used by your users. After all of that is done, you can reiterate again and maybe improve the performance, maybe fix the mistakes, maybe implement additional features and additional functionality for the whole solution. But you do that in a one by one iterations in a very agile manner. Okay, I was speaking a lot, but what I wanted to finish up with is to say, please get involved. So please comment what are your rule of thumbs from the production ready code. Of course, please subscribe and like this video. And yeah, get ready and stay tuned for the next video on CI/CD pipelines or any many other topics that I will cover on this channel for the DevOps and programming in general. So have fun writing the good code and fixing the bad code into the great shape. Have a nice day.